Okay, let's start with the first part of the tutorial. In this part, we are going to discuss that how can we calculate the even and odd component of any given signal here. Okay, so the formula is straightforward. We are given the signal xe of t, like this will be the even component and odd component here. And basically the given signal is x of t here. Okay, and this is a continuous time signal here, as we know from this t here, as we discussed earlier here. So what we have in the formula basically we have two terms here. You can see here we have half x of t and we have half x of minus t here for both even and odd parts. Okay, one time we are adding them to get the even component, one time we are subtracting them to get the odd component here. So what I will be doing here, I will take an approach to calculate half x of t and half x of minus t first. Then we first time add to get even, and then we subtract to get the odd component here. Okay, so it's quite simple here. Half x of t means basically we are amplitude scaling it by half here. So means my amplitude from 4 will become 2 here. There will not be any change along the time axis, as I am not changing the time here. Okay, so there is no time operation, the only operation is the amplitude operation here. So let's solve it here. So what we will get here, basically draw it. So we are going to have this is t here. Okay, and I'm going to, for example, this is 2 here, so from minus 1 up till 2 here, and then we are going to have it will be here, and for example this is 2 here, and here this is 2 here. So basically when I am not writing it here, I'm writing it here because it will be x of t, and we have amplitude scale it by half here. Okay, this is what we have done so far. Similarly, we need to find half x of minus t here. Okay, half x of minus t is nothing but flipping the half x of t here. Okay, if you want, you can first do the flipping and then you amplitude scale, so you will end up with the same figure as what I am drawing here. So basically I have this signal here, for example. Now flipping means I'm going to have a signal between 1, and this will be basically minus 2 here, and this is for example 2, so I'm going to have something like this here, if I'm not wrong here. Okay, so basically I have drawn half x of minus t here, and this is your t here. Okay, so I think it's quite clear now. So basically what we have drawn the signal, half x of t and half x of minus t. Now for even, we need to add them. We will add them to get the even component here. Okay, so I'm just moving it up here, and I will add them to get the even signal here. So let me make it here. So my even signal will be, now you can see here my signal is starting from minus 2 here, and this is starting from minus 1 here, and this is ending at 2 here, this is ending at 1 here. So we will decide few points here, and those few points we are basically going to calculate the addition values, and then we will simply join them. Okay, because we cannot calculate each point here. So what we have, let's suppose I am going to calculate at minus 2, minus 1, 0, then 1 and 2 here. Okay, now what we have here, if you see here, basically my signal here at minus 2, the signal value here is 0, the signal value here is 0, so 0 plus 0 will give me 0. So basically I will end up at some point 0 here. Okay, so at minus 1, what we have, the signal value here is 0. At minus 1, if you find it, basically if you see here, if you draw it here, if this is 2 here, so it means this is going to be 1 here. So at minus 1, this signal value here is, or this point here is 1 here basically. Okay, so 0, so 0 plus this 1 will give me 1. So 0 plus 1 will give me 1. So let's suppose this is 1 here, so I say this point is here, somewhere here. Okay, let me draw it here. Let's suppose that this point is here. Okay, now next thing here is add 2. At 2 the value here is 2, the value here is 2, so 2 plus 2 will give me 4. So let's suppose I will end up at certain point 1 2 3 4. Let's suppose my 4 is some point here. This is my 4 here. Okay, so next will be at 1, this at 1, this will be again 1 here, and this will be 0. So 1 plus 0 will give me 1 here, so my signal will become 1 here. And at 0, obviously this is 0 and this is still 0, so 0 plus 0 will give you 0. So we have already calculated the points here. Now the step is simply join them, but please join in the same order you have calculated. So basically my first point here, then my next point here, then next point here, and then next point here. Okay, so this is basically nothing but this is your signal X. I'm just this is T here, this is X, E, of, and here, so even component here. Okay, and remember, whenever you calculate it, it should look like even signal. So even signal is nothing but this is symmetric along the axis here, along the vertical axis here. I mean, if I have some point here, for example, if I have some point here, I will have the same point on the on same value on the opposite side. Means at 1 I have some value here, at -1 I have another same value here. This value, like at 1.5 and at -1.5 I have the same value. So we said that these are symmetric here. Okay, now for the odd we will do the same thing again for odd, but instead of addition we are going to perform the subtraction here. So basically how we will do the subtraction here again. Okay, let me take another take this one. Now what we have, I'm just using the blue here. Okay, blue, let me check. I'm just changing it to the, for example, the pink highlighter. Okay, now again the value at -2, at -2 I will be doing at -2, -1 0 1, and this is 2 here. Okay, now at -2 the value here is 0, the value here is 0, so 0 minus 0 will give me 0 here, so it will be the same point here. Okay, next thing is at -1 the value here is 0 minus 1, so 0 minus 1 will give me -1 here. So let's suppose my signal, I said that this is -1 here, so I'm getting some value here, for example this is, let's suppose, -1 here. Okay, now at 0 this is 2 and this is 2 again here, so 2 minus 2 will give me 0, so at 0 basically it is 0 at the orange here. Now at 1 this is 1 and this is 0, so 1 minus 0 is basically equal to 1, so at 1 I will get some, for example I will get this thing, this is for example 1, let's assume this is 1 here, 1 here. And at 2 basically this is 2 0 minus 0, so 0 minus 0 is 0, so basically at 2 I have 0. So now simply join them in the same sequence you calculated, like I join this one, then I find this thing, and then I join something here, and this is nothing but this is your odd part of the signal. Sorry, I just made one small mistake. This is T, this is T, okay, not the N, please. So this is XE of T, and this is X of T here, continuous time signal, not the discrete time signal, okay? And the axis here will be T here, the axis here will be this thing here. Clear with this? So this is how we calculate the even and odd. Again, in case of the odd symmetry, whatever value I have here, I should get the opposite value on the other side. Like for example, at 1 I have 1, so at -1 I am getting -1 here. Similarly, for example, at 1.5 I have the 0.5 here. So at -1.5 I have -0.5, 1.5. minus 0.5 here. Okay, so this is how we calculate the even and odd parts for the continuous time signal here. Thank you.